This video will focus on sections 4.2 and 4.3, and we're going to be looking for perimeter and area formulas for each of these items. So we're going to start with rectangles. Let me go ahead and pull one up. This program will allow me to draw them. There's a basic figure of a rectangle. Typically, they're labeled. I'll label one side with an L and the other side with a W, meaning length and width. The other two sides are the same as the two sides given, and all of these angles meet at 90 degrees. So we have four sides. We have two pairs of parallel sides, and the angles are all 90 degrees. For the perimeter, is the length around the outside of the rectangle. So if we use my mouse here to tell us, what I'm talking about is the sum of the lengths of these four sides. So the perimeter, formula for the perimeter can be L plus W plus W. That's the sum of the four lengths. More simplistically, it's 2 times L plus 2 times W. So let me do an example. And I would like to compute the perimeter of the given rectangle. So let me go ahead and draw one in here. So this one we have is the length is 11 centimeters. The height is 8 centimeters. So the perimeter is going to be 2 times L plus 2 times W. The L in this case is 11. I'll put in the units when I'm done with the problem. And the width is 8. So that's 22 plus 16. That equals 38. Now remember, that's not quite the answer. The answer that you want to give, if I can actually write that word, is 38 centimeters. You're measuring the distance around the outside, and distance is a measure of length. A square is our next figure. It's it's a rectangle. A rectangle where all the sides are the same length. It's a little bit different. In the perimeter, all we're guaranteed to is that the length of the length is the same at the bottom and the top, and the width is the same at the right and the left. With a square, all of those sides are the same, so it makes all of our formulas a little bit easier. Now I'm going to have to try to estimate whether I have a square in here. I'll try to make it look squarish as much as possible. But in this case, then every side could simply be called L. And then when you're doing the perimeter, you add up all those L's. There's four of them. I don't care if you call them all W. Call them whatever you want. this here will be 4 times L. There's the formula for the perimeter of a square. So as a quick example, compute the perimeter. And I'll go ahead and draw us another square if I can get myself to do that. Let's see. I'll make a little bit bigger square than before. I guess that looks square enough to me. All right, this time they only have to give you one length, because the assumption here, since it's a square, all these other lengths are also 26 meters. So the perimeter is going to be 4 times 26, which is 104. But remember, when you actually write your answer, to put the units in there. So in this case, the units are measured in meters, so we have 26 m for the length around that figure. For areas, we have the same formula for both. So let me go ahead and draw in a rectangle. So I might have an L and a W here, or a square. In a square, all I got to do is give you one length. So the area for a rectangle we have the area is the length times the width. For a square, the area is also length times width, but since the length and the width are the same, it's like length times length, so it's a squared. So then when we do an example, I'll do one full with all the units and everything in play while I do it, and the next one I'll do it without all those units in play. But let's suppose I have the following rectangle. And this measurement is 3 centimeters, and this measurement along here is 9 centimeters. So find the area. Well, when you do the area, you take the length times the width. So I'll take 3 centimeters times 9 centimeters, and what you get is 3 times 9 will give you the 27, but then you got cm times cm, so that makes 27 cm squared. So your units will all have that little square on the top of them, because you're literally multiplying a length by a length to get square lengths. Same question now for a square. Find the area this time. All I'm going to give you is 9/10 m. So 9/10 of a meter. So the area, I'll call it A, is equal to 9/10. I'm going to drop, I'll put the meters squared at the end of the problem. Just remember, we're going to have meters squared. But I'll just do this for now. The meters, the m will get in the way of if the calculations get complicated. So when you do this 9/10, you might remember that you do 9 squared divided by 10 squared, and that's 81 over 100. Otherwise, you might do this. Instead, you might take 9/10 times 9/10. And what you should know by now when you multiply fractions is that you multiply through the top, so 9 times 9, and you multiply through the denominators, 10 times 10. And you can see that you're going to get exactly the same thing that I had over here. You're going to get 9 squared over 10 squared. All right, that gives us the numerical part of the answer, but the answer itself needs to have the units in it. So 81 over 100 m squared. The next figure we'll be looking at are parallelograms. They're four-sided, where we have two pairs of parallel sides. And two pairs of sides with the same length. It's probably a lot easier just to draw one of these things to show you than to write all that stuff out. So let me go ahead and grab one of these. It has a picture of one here. It's kind of what I want. I think I could flip these around and whatnot if I want to, but this is good enough for right now. So what I want to do is look at both the perimeter and the area. So for this, I'm not sure, I don't know if length is the best thing to call this. I might call this by the letter B for base, but the height is a little bit different. The height is not this length here. This length here is just a side length. I don't know what I'll call it. Maybe I'll use the letter S. I don't know what's a good one. But the height is measured from this tip straight down to the base. And then let me call this an S. And then we have a B up here, and this is also an S. So anyways, the perimeter that's the same thing as before. We're going to add up all the sides together. So I'm going to take B plus S plus S. And I'll get something similar, 2b plus 2s. That'll be the perimeter formula. Basically, the perimeter is always just adding up the outsides. You really don't have to memorize a formula. Just add up all the side lengths and you're done with that one. Now, area is always a little more complicated. For this, the area is going to be the base times the height. Let me do an example. Compute the perimeter. And let me pull up one of these things. I don't know how easy it is to adjust them to make them kind of like I want, but I think I can do that with them, or I can make them long like so. And in my case, I want to do a long skinny one. Oh, I think you could do it this. Here we go. Ah, there we go. That's what I'm looking for. I want a long skinny one, and its lengths, I'm going to put 1 meter here, 5 meters here. So the perimeter is going to be 2 times the 5. Remember, the length up here is also 5, and the length on this side is 1. Plus 2 times 1, that will be 10 plus 2, that'll be 12. Now, since we're talking about perimeter, we're talking about length. So the answer will be 12m. Next, let's compute the area of one of these things. Let's see, down here I have 12 meters, and for this length here, this height is 7 meters. So the area is 12m times, well, as I said before, I'm not going to include the units while I'm doing the multiplication. I'll put those units in after the fact. So I have 12 times 7, which equals 84. So our answer is 84 meters squared. Moving on, our next figure are the trapezoids. Here you have 4 sides with 2 sides parallel. Let's take a look at what one of these pictures looks like. I do not have one here, but I can grab one off the internet, so let's go ahead and do that. Yeah, that might be the best looking one that I'll have. I'll grab that one. So here, what we'll have in this case is we'll have a big base, and we'll typically have a little base. I don't know what they call these side lengths, but I'm just going to call it, I don't even know a good phrase, call it side length 1 and side length 2, and we'll be measuring the height just like we did before with this little mechanism on the side. So for the perimeter, that's easy. You just add up all the side lengths. So I'll have the big B plus the little b plus S1 plus S2. And unfortunately, there's no way of simplifying that thing. The area, that'll be 1/2 times the height times the little b plus the big B. Little b is the little base, and big B is the big base. So here's the formulas. And please, I don't think you should memorize the formula for perimeter. Just add up all the side lengths and you'll be good. Let me do a couple of examples. Let's compute the perimeter. Now, what I'm able to grab as far as shapes are concerned is I can grab only very certain shapes from the computer or from online. So not trusting that, I'm going to draw in some of these by hand. Although they may not look great, I'm going to draw them in anyways. This is in fact what I would do on a whiteboard. So there's my crappy looking figure. We have 5 centimeters for the small base, 7 centimeters for the big base, 3 centimeters for one side, and 4 centimeters for the other side. So the perimeter, I'm just going to add up all those numbers. So I'll start with 7, then add 3, then 5, and then 4, for a total of 19. So our answer then is 19 cm. Throw in your units. And then let's compute the area. This time I give you the big base, 8 meters, the little base is 6 meters, and then this height is 4 meters. So the area is 1/2 times 4 times the little b plus the big B. And that equals 1/2 times, I'm going to put the 4 over 1, you might find that beneficial, and then the 6 plus 8 is 14 over 1. So I can take out this 1/2 by canceling with the 4, and I'll be left with 28. And now let me put in my units, that is meters squared. So now let me throw a few of you at random, throw a few at you at random for practice. So for each of these, I won't say the figure name. You'll have to figure it out based on the context of the problem. What I would recommend you doing if you're watching this video is to wait till I write down the question, pause the video, you try to do it on your own, then replay the video to see if you got it right. So let's find the perimeter and area. And once I give you the figure, you'll almost certainly know how to work it once we have the figure. But we're also going to practice some of your arithmetic. So here's what I'm talking about. I'm going to give you one length will be 5 1/3 feet. The other length will be 1/2 feet. So for the perimeter, we're going to do 2 times the 1/2 plus 2 times the 5 1/3. Now I don't know about your class, but my class, I typically have them turn mixed numbers into fractions before you typically do anything with them. And when you're going to multiply or add or anything like that, I like to have them just as regular old fractions. But this is nice here, that between the 2 and the 1/2 I can cancel and just get a 1 in that spot. For the other part, I'm going to write the 2 as 2 over 1 just in case I can do some simplifying. The 5 1/3, you may remember the formula for that is we take 5 times 3, which is 15, and then add 1 to it. So you get 16 over 3. Well, I can't do any simplifying there. I'm going to get 1 plus 32 over 3. And if I want to add these two together, I'll rewrite the 1 as 3 over 3, and the 32 over 3 will stay. And I'll get 35 over 3. Now, depending on the problem or who is asking you the problem, they may require you to change this answer to a mixed number. So what is that if I rewrite it as a mixed number? So to write how do we do this? Well, I do long division. 3 goes into 35. Well, how many times? Well, let's follow this. 3 goes into the 3 one time, so I put a 1 directly over the 3. Then I do 1 times 3 is 3. And I subtract. 3 minus 3 is 0, but then I can bring down the 5. 3 goes into 5 one time. Subtract. And I have a remainder of 2. So 35 over 3 is the same as 11 2/3. So for our answer, you can either put 35 over 3 feet, since we're talking about perimeter, or 11 2/3 feet. It just depends on who's asking the question, what format they'll want you to have the final answer in. Let's find the perimeter. Oh, before I find any perimeter, I should probably go and find the area of this creature, because I didn't do that yet. So this was the perimeter. That was perimeter. The area, then, I have to do base times height or length times width, or whatever way you memorize it. So for the area, the A will equal the 1/2, which was the bottom number, the length of the base, times 5 1/3. As before, I'm going to change this 5 1/3 to a fraction. So it'll be 16/3. This time I'm able to cancel something. So it looks to me like my answer is 8/3. Now, since it was in feet, we'll have 8/3 feet squared. However, if I should want to write that as a mixed number, do the same thing as I did before. 3 goes into 8 twice, with a remainder of 2. So we have 2 2/3 square feet as well. So either one of these answers should do. If you, I personally wouldn't care, but your teacher may want you to write those things down. It depends on the format. They may ask you to do the mixed number as your answer. Typically, mixed numbers are for display purposes. People are easy to understand something like this. This format is not typically good for display purposes, so people have a hard time understanding what that means. So anyways, check with your instructor for the final answer. All right, moving on. Find the perimeter and area. So this time, what do I have? I don't intend, well, you'll figure it out, I hope, but I don't. Let's see here. I think that might be good enough. So what all do I need to give you here? I'm going to give you this length, which I see. I want to make this longer. And let's do that with it. So for this length here, I'm going to call it 6 inches. For the length down here, I'm going to call it 3 1/2. And then for the height of this thing, if I can accurately draw this in, that number is 4 1/3. So for the perimeter, we just want the side length. So I want this side plus this side plus this side plus this side. Remember, this length up here is 3 1/2 inches as well. This length of this side over here is 6 inches. So we're going to do 2 times 3 1/2 plus 2 times 6. I'll write everything as fractions when I need them. 2 times 6 is just 12. Very convenient here that the 2's cancel, and you'll get 7 plus 12, which equals 19. So our answer for this will be 19 inches. For the area, we're going to do the base, which was 3 1/2, times the height, which is 4 1/3. The 3 1/2 turns out to be 7/2, and the 4 1/3 is 13/3. When I look up here, 7 will not cancel with either the 2 or the 3, and 13 won't either. So I just multiply it out, and I'll get 91/6. And once again, we have to put in our units. So 91/6 square inches or the mixed number format of it, I'll take 6 and put it into 91. 6 goes into the 9 once. I subtract, I get a 3, and I bring down the 1. 6 goes into 31 5 times with a remainder of 1. So that looks to me like 15 and 1/6 square inches. So either one of those answers should work for you. All right, next figure. Once again, I can't rely on the computer to give this one for me, so I'll see how well I can draw it by hand. So this is my version of a trapezoid. This length here is 8 1/2 feet. This length up here is 11 feet. This length is 7 feet. This length down here is 6 3/4 feet. And then the height, if I'm going to do area, I'm going to need this length as well. Sort of an upside down, so we're going to have to reacclimate our bases and things like that. So I'm going to have 5 1/3 feet for that one. So let's go ahead and get the perimeter. Here, there's no real formula other than just add up all the sides around the outside. So I'm going to have 11 plus 8 1/2 plus 6 3/4 plus 7. What I'm going to do is, I notice that I have fractions with a 2 in the denominator and a 4 in the denominator. So what I'm going to do in preparation for having all fractions to deal with, I will write my whole numbers over 1. And then I'll keep them that way for a minute, because what I'm going to do is write the rest of these mixed numbers as fractions. So the process is 8 times 2 plus 1. That gives me the 17. And then the 6 times 4 is 24 plus 3 gives me the 27 over 4, and then 7 over 1. Now the LCD of all of these fractions is 4. So I'm going to rewrite everything over 4. So the 11 over 4 becomes 44 over 4. The 17 over 2 becomes 34 over 4. Then we have 27 over 4. And then I have 28 over 4. Check all those numbers. When I add them up, it'll be something over 4. So let me go ahead. 44 plus 34 is 78. Plus 27 is 105. Plus 28 is 133. So my answer is 133 over 4 feet. Or if required to write it as a mixed number, let me do that. 4 goes into 13 3 times. Put the 3 right above the first 3. 3 times 4 is 12. Subtract and drop down to 3. And I see that 4 goes into 13 3 times again. And the remainder is 1. So what I'll get then is 33 1/4 feet. So either one of those should work for your perimeter. For the area, this one I'm going to do 1/2 times the height. The height is 5 1/3. And then times the sum of the small base and the big base. The small base is 6 3/4 and the big base is 11. Now your job is to work the parentheses first. So that's exactly what I'm going to do. The other numbers are just going to write it out until their time comes. So what I'm going to do is change the 6 3/4 to 27 over 4 and fix this with a giant dot. Now the 11, I need to rewrite it. Think of it as 11 over 1 so that I can write it as 44 over 4 inside of there. Now I can go ahead and add those things inside the parentheses. When I do that, I'm going to get 27 plus 44. I think that is 71. And so I'm going to get 1/2 times, I'm going to change this mixed number to a fraction. That'll be 15 plus 1, that'll be 16 over 3, and then 71 over 4. You should do as much canceling as you can here. Like for instance, I see the 16 and the 2 can cancel, and that will leave me with an 8 in that spot. Now, I see another canceling between the 8 and the 4. I can cancel and put a 1 there. I should put a 1 left over. 4 goes into 8 twice. So let me see what all I have left. On the top, I have 2 times 71. So I have 142 over 3. So my answer is 142 over 3. And my units were feet. So we need feet squared. And then I put the equals because I'm going to do long division to change it to a mixed number. 3 goes into 14 4 times. 4 minus 2, drop down the 2. 3 goes into 22 7 times, with a remainder of 1. So it looks like 47 1/3 feet squared. Now, the last figure that we're going to do in this section are quadrilaterals. What can I say about these things? They're four-sided. That's it. They don't have any rhyme or reason. They're just four sides. So we do not have a formula for the area of one of these things. So no area formula. And we don't technically have a formula for the perimeter, but for the perimeter, it equals the sum of the side lengths. Remember, it's the length around the outside of the figure. So if I have something like this, these can come in all sorts of crazy shapes. I don't know, something like this. This will say. If I have a length A, B, C, D, the perimeter is you literally just add those things together, and that's the end of it. So I'll do one example here. Compute the perimeter. And the figure I have, it's going to look like this. And the lengths that I have, here's 3 3/4 meters. That's 3 3/4. Then this length is 6 1/4 meters. And then this length is 7 meters. And the last length is 5 1/3 meters. So for the perimeter, just add up those lengths. So 5 1/3 plus 7 plus 6 1/4 plus 3 3/4. I'll put in my units later. I'm going to change all these mixed numbers into fractions. So 5 times 3 is 15 plus 1 is 16 over 3. I'm going to write 7 as 7 over 1 because I'm going to be dealing with fractions. 6 1/4, take 6 times 4 to get 24 plus 1 will be 25 over 4. And finally here, 3 times 4 will be 12, plus 3 will be 15 over 4. So from this, hopefully you can see the LCD is 12. So I'm going to have to write all of these fractions over 12. Let's start with the 16 over 3. In order to change this 3 to a 12, I needed to multiply by 4. 16 times 4 is 64. Same thing here. In order to change this 1 to a 12, I multiply by 12. 7 times 12 is 84. For this one here, I need to multiply 4 by 3 to make it 12. 3 times 25 is 75. Finally, I had to multiply this 4 by a 3. 3 times 15 is 45. Let's go ahead and add them all together. 64 plus 84 is 148. 148 plus 75 is 223. 223 plus 45 is 268. And this is nice because I can simplify. I can cancel, let's see, I think a 4 will go into both of these numbers. 4 goes into 12 3 times, and 4 goes into 268. Let's see how many times. 6. 67 times. So I get 67 over 3. Our units were in meters, so for my answer I can do 67 over 3 meters, or long division. That'll be 22 1/3 meters. And that takes care of all the material from section 4.3. For section 4.4, we're doing the same thing except for one figure, the triangle. We've decided to put triangles by themselves. They have a little bit different formula than everything else because they don't have 4 sides, so I guess that's why they're different from everything else. I'm going to see if this will allow me to make triangles that are not isosceles. Well, it generally will not. You can see I'm kind of forced to have that. So I'll just delete that thing, and I'm going to have to draw by hand. So for a general old triangle, what we'll have is we'll have a base, and then, I don't know, I'll call this side 1, side 2, and then you'll have this thing again, which is the height. So for the perimeter, you add up all the side lengths, so S1 plus S2 plus B. But for the area, you do 1/2 little b times h. So those are the formulas that govern the triangle. And once again, I wouldn't recommend memorizing a perimeter formula because they are so easy. So let's do an example to illustrate this stuff. Let's compute the perimeter and area of the following figure. Here, I happen to have a right triangle. This side is 3 feet, this side is 4 feet, and this side is 5 feet. So the perimeter, P, will equal 3 plus 4 plus 5 will be 12. So for the perimeter, we'll have 12 feet. For the area, that'll be 1/2 base times height. Well, here, since it's a right triangle, the height is 3. The base, of course, is 4. So 1/2 4 times 3. A little simplifying, notice the 2 goes into this 4. I can make this a 2 and make this a 1, and that'll be 6. So remember, it'll be 6 square feet will be the area. Another example, find the perimeter and area. This time the triangle is placed in a weird way. And then we have this side length all the way there. So here, this little height thing is 2YD for yards. So we have 6 1/2 yard. Then I have 10 1/5 yard. And then finally 3 yard. Oh, let me put my little square down here so you know it's a right angle there. So for the perimeter, we just add up those side lengths. So it's going to be 3 plus 6 1/2 plus 10 1/5. Changing to fractions for everything. You can check these numbers on your own. However, I do know the LCD is 10. So I'm going to want to change all of these fractions to being over 10. And now let's add them all together. 30 plus 65 is 95, plus 102 is 197 over 10. And so I don't know here, neither 2 nor 5 will go into 197, so that's as simplified as you're going to get. So we get 197 over 10 YD, since we're just doing a length calculation. Or as a mixed number, it will be 19 7/10. Once again, check those numbers out. For the area, that'll equal 1/2. The base is 10 1/5, and the height is 2. I'm going to use a little bit of advanced simplifying skills, and I'm going to cancel this 2 with that 2. And so we'll be left with just 10 1/5. Well, that's beautiful. Our answer is 10 1/5 YD squared. Or if you want to put it back to a mixed number, you'll get 51 over 10 YD squared.